The cosmos is not a painting. It is a machine, a clockwork of gravity and momentum, ticking in a silence so profound it mimics peace. For 4.5 billion years, our solar system has enjoyed a rare luxury, solitude. We drift through the galaxy in a bubble of relative calm, but space is not empty, and it is not static. There are wanderers in the dark, stars ejected from their birth clusters, untethered by any orbit, drifting through the void at millions of miles per hour. We call them rogue stars. What happens when the solitude ends? What happens when a stranger walks into our home? It does not need to hit us to destroy us. It simply needs to pass by. The invasion begins long before we see the intruder with the naked eye. It begins here, the Oort Cloud, a spherical shell of icy debris extending nearly a light year into the void. Gravity is a relentless force with infinite reach. As the rogue star, perhaps a red dwarf roughly half the mass of our Sun, grazes the edge of this cloud, its gravitational wake acts like a hand sweeping through a swarm of gnats. This is the first phase, the bombardment. The star destabilizes the orbits of millions of frozen bodies, sending them plunging toward the inner solar system as massive, volatile mountains of ice. For decades, Earth's night sky would be a gallery of tails and streaks. While the gas giants might absorb many impacts, the sheer volume ensures Earth would face a firing squad of cosmic proportions. But the comets are merely the dust kicked up by the approaching tires. The vehicle itself is coming, carrying a weight that will bend the spine of the solar system. We often think of planetary orbits as fixed tracks, but this is an illusion. Our solar system is a delicate, chaotic equilibrium, with planets held in place by subtle gravitational tugs. A physical impact between the rogue star and the Sun is statistically impossible due to vast distances. The true assassin is gravitational scattering. As the intruder dives through the ecliptic plane, it introduces a new, massive variable, creating secular resonance. The intruder tugs on Jupiter, which then shifts its massive bulk, cascading down to the smaller, rockier worlds. The clockwork breaks. Earth's orbit elongates from a near circle to a stretched oval. We spend months swinging dangerously close to the Sun, scorching the atmosphere, only to be flung out into the deep freeze. The delicate climate that allowed civilization to rise is shattered in a single orbital period, leading to extreme climate chaos with CO2 spikes and alternating ice ages. As the star recedes, it leaves behind a system in chaos. For Earth, calculations suggest two grim scenarios, the fried and the frozen. In the first scenario, Earth is pulled into a tight spiral toward the Sun. The oceans boil, the atmosphere is stripped away, and Earth returns to the molten state of its infancy. The second, and perhaps more haunting scenario, is ejection. We are slingshot by the gravity of the giants, cast out of the solar family entirely, becoming a rogue planet ourselves. Drifting in the eternal night, the surface would freeze to near absolute zero. Yet, deep below, life might persist near geothermal vents, unaware their star has abandoned them. This sounds like the stuff of nightmares. But the galaxy is ancient, and these encounters happen. Rogue stars, like Gliese 710, are real interstellar wanderers. Gliese 710, an orange dwarf, will approach our solar system within 13,600 Australian dollars in 1.29 million years, perturbing the outer Oort cloud and increasing comet flux.